so here's our Prometheus chart, and it's syncing up. As you can see, there are lots and lots and lots and lots and lots of resources. Oh yeah, it doesn't stop. Hello there and welcome back to my YouTube channel. For those who are new here, my name is Anais, and usually I make videos related to Kubernetes and the cloud native ecosystem. Now in this video, I'm going to show you how you can use ArgoCD for your GitOps workflow, but specifically to also manage your security tools. And in our case, we're going to use Starboard for our security scans and to get detailed insights on the security, on the vulnerabilities and misconfigurations inside of the resource, the workloads running inside of our Kubernetes cluster. If you're completely new to Starboard or ArgoCD, check out the videos linked up here now. First one and second one, okay? And then come back to this tutorial. Now we're going to see how to set up ArgoCD. We're going to see how to define Helm Charts to be deployed through ArgoCD declaratively. So basically writing the YAML manifest to deploy those Helm Charts. Specifically, like in the previous videos, we just told ArgoCD about the Helm Charts. We didn't define them declaratively themselves, which is GitOps best practice, which we're going to do in this tutorial. Then we're going to define it declaratively, how to set up the Helm Charts for ArgoCD for Starboard, through an application, for a Starboard Exporter to get the metrics out of Starboard and inside of our monitoring stack, which we're also going to deploy through ArgoCD. So everything is running through ArgoCD, but security best practices, security tools as well, not just our application, not just our application workload, not just our monitoring stack. No, also our security tools. Everything is running through Kubernetes, through the Kubernetes API, and managed through ArgoCD. How exciting is that? Now, if you like these kind of tutorials and you want to see more of these kind of tutorials, please make sure to give it a like and subscribe to my channel for upcoming videos. If you don't like listening to my voice, if you don't like video content, below is the blog post, linked below in the description, so check out the blog post. If you have any comments, suggestions, feedback, any thoughts, if you want to give me a thumbs up and a yay, comment below. And let's get started. So from the ArgoSecurity GitHub account, we're going to go to Starboard. This is the Starboard repository. Here you will find an overview of Starboard, the advantages of Starboard, and basically just the overview of what is Starboard about, outline. Now, again, for those who are new, check out my previous video that goes in more detail over what Starboard is and how does it work and so on. Now you can see there's a Kubernetes operator that can be deployed within your Kubernetes cluster to manage basically your security from within your Kubernetes cluster as a Kubernetes resource. However, you can also use the Starboard command. And that's, for example, practical if you just want to have a one-off security report, but also if you want to run Starboard within your CI/CD pipeline, for example. Now, we want to go ahead and we want to use the Starboard operator. Specifically, we want to install the Helm chart through ArgoCD. Now, here is all the information that we need to on how the Helm chart is going to be deployed. So it uses from the Aqua Helm repository, the Starboard operator. It's going to deploy it in a namespace Starboard system. In this case, the command is going to create, or it's going to tell basically your cluster to create a new namespace called Starboard system, if it doesn't exist. And then it's going to set two values in that case. And this is the version that should be deployed, right? Now these values can either be set through Helm install, these are Helm values, or you can specify them within a values.yaml file as well. Now this is important because we want to also specify some of the Helm values when we deploy the Starboard operator through ArgoCD, right? Now, we're gonna first go through the Getting Started guide on ArgoCD, on our cluster. So this is our Kubernetes cluster. Get nodes. It's a 4-node cluster running on JKE. And here we're gonna first of all get namespace, create new namespaces. So we want to have kubectl, create namespace ArgoCD, and then we want to create an app namespace, the Starboard system namespace, and then lastly a monitoring namespace for everything that we want to deploy within our cluster. So as you can see, these are the things that we want to set up within our cluster. So next, we want to deploy all of the resources for ArgoCD, right? So we are just going to go ahead and deploy all of the resources. Now this is going to take some time. As you can see, there's lots and lots of stuff that's going to get deployed. Now we can have a look at our Kubernetes cluster and see all of the resources spin up. So as you can see, this is the namespace ArgoCD. Those are the different, well, services in that case. We can also go to namespace ArgoCD, and then we can see the pods being spun up. Now we're going to wait a second for them all to run. One more second maybe. And once they are all up and running, which is kind of now, we can now go ahead and we can access ArgoCD, the UI. However, you want to make sure that you have ArgoCD, the CLI installed. That's going to become very handy once you want to sync applications. Now you can install it just through brew install ArgoCD. That's an option. There are other options that are listed here in the documentation, CLI installation in the documentation, okay, where you can find further options on how to install it. Now we want to go ahead and we want to patch one of our services so we can access the UI. Now in this case, I'm going to patch it into a load balancer. However, if you're going to use ArgoCD in production, you want to have a specific ingress just for your ArgoCD service that you can access this properly, right? Now, once we have done that, we can go ahead and we can port forward it to localhost 8080. Now, at this point, we can log into ArgoCD, but to log in, we need a secret. And that secret is going to come also from the documentation. So this is our login secret that we're going to use. So our login secret. And now we can say ArgoCD login localhost 8080. We're going to log into ArgoCD. And the username is admin. And then we're just going to provide this secret, the exact same secret, right? And then we're logged in. Now that we are logged in, we want to deploy things on ArgoCD. So here's the UI. We can go into advanced, accept risk. Now this is the UI. We're gonna log in here with the same password. Don't save. And as you can see, there's nothing running right now, right? Now I have here this application that's also linked below in the description where you can check out all the YAML manifests that we're gonna use, okay? And here I have a Starboard directory. And basically what we're gonna do, we want to deploy this ArgoCD Starboard YAML manifest. We want to deploy it to our cluster. Now, how do I know how to do this, right? Where is this coming from? In ArgoCD, you can find the user guide, right? And here's a Helm user guide. And here it tells you how to specify Helm declaratively. Now, in the past, in my previous ArgoCD videos, also on GitOps, I didn't do it declaratively. I didn't specify a custom resource for ArgoCD of type like an application for the ArgoCD API that tells it how to deploy the Helm chart. Now, these are all the information that we've seen here in the Starboard deployment, right? These are the same information that we need. And this is how we know how to specify this resource. And this is ultimately how I came up with this resource that has to be deployed, that has to be given to ArgoCD, okay? Now, I want to give this to ArgoCD, right? And tell ArgoCD, here's all the information that you need to deploy my Helm chart properly. Here's how you should sync that Helm chart and everything basically that we would otherwise specify, for example, through the ArgoCD UI, right? But if we specify through the ArgoCD UI, it's not declaratively. Versus if we just tell ArgoCD about this application, right? Then later on, we can make updates directly to Git, which is GitOps best practice, and ArgoCD will then look at the information here and compare it to what is running inside of our cluster, right? So let's assume, let's draw it. Let's assume this is our application repository, right? And here's our code within, like, I don't know, some code, right? And then here we have our YAML manifest that tells basically ArgoCD of how the application should be deployed. App deploy Helm or something, right? So this is basically what I've shown you here, right? This is what I specify here. And once there's an update within the repository, we want to then update the YAML manifest, right? For example, we want to increment the version, right? That could be one thing we want to change, to increment the version here. And this could be done through a CI/CD pipeline. Oh, this again. This could be done through a CI/CD pipeline, and pretty. That runs when we push, for example, to the main branch, right? And this is responsible to then increment the version over here. And then we have ArgoCD running within our cluster. So this is our cluster. And within the cluster, we have ArgoCD. And we have our app namespace. And we have maybe a bunch of other namespaces, right? It doesn't matter. But ultimately, ArgoCD is responsible to monitor this, right? This is the GitOps mechanism, that we have a controller, something living within our cluster that knows what it has to monitor. It's monitoring this consistently, like on a frequent basis, right? Depending on what our sync policy is that we specify over here, right? So it's monitoring that YAML manifest and making sure that this is the same, right? That these two are the same. That the desired version, which is this manifest, is the actual version that's running within our cluster, right? And if that's not the case, then ArgoCD has to pull the update from the YAML manifest, from the Git repository, and deploy it. This is ultimately how it works, right? And the benefit of that is that we only have to give ArgoCD access from within our cluster. We don't have to give an external application access to our cluster, right? ArgoCD knows where the Git repository is. ArgoCD knows how to pull from it. And then ArgoCD has within our cluster the rights to deploy the updates, right? So in this case, I obviously don't have the application like running within here, right? Like this is not an application repository. Also for my app, .yaml manifest that we're gonna see in a second or later, we don't have the according repository. However, for example, for the app thing, right? It would make sense if the YAML manifest lives within the repository and the GitHub action, for example, can easily increment the version or make changes to the YAML manifest. So ArgoCD knows that there's an update, that there's, for example, new Kubernetes manifests that have to be pulled from Git. And this YAML manifest knows where to pull it from. So in this case, no, not here, we tell it that this is the Helm repository where the Starboard operator lives, and this is the version we want to pull from, right? This is ultimately how it works. So with us being connected to our Kubernetes cluster, we can just specify kubectl apply to namespace ArgoCD, and then we're going to apply the YAML file that I just showed you, okay? And that I just showed you how I created it. So we're going to see what happens. And Starboard got created. Awesome. Now let's check it out in the UI of how it looks. Now, as you can see, it's right now processing Starboard. So it's right now basically syncing the actual version that's running within our cluster with the desired version that we defined in GitHub, right? So if we make any changes to the version in GitHub, it will then try to sync it with the actual version within our cluster. Now, it can't sync the specific CRDs from Starboard. It can't do that, so just ignore the yellow errors, right? Just ignore that. It's all Good, right? This is all good. This all worked. Now that we have Starboard running, we want to deploy our application, right? And we want to make sure that we can see any reports that our application relates to, that relate to our application inside of ArgoCD as well. In my ArgoCD Starboard repository, I have an app directory with an app.yaml file, and that app.yaml file looks slightly different to what we've seen just now for deploying the Helm chart. So in this case, I'm specifying the Git repository that has my Kubernetes manifests, and this is how you would do it declaratively, right? Now, that's also what I showed you here in Excalibur, right? This is where basically we have the declarative way of defining how we want our app to be deployed through ArgoCD. And if this is part of our application repository on GitHub, right, what we can do then is through GitHub Actions update, for example, we would update the manifests, right? And whenever we update the manifests in our repository, this is when ArgoCD detects that there's a change between the desired version in Git and our actual version within our Kubernetes cluster and would make the update happen, right? So now we're gonna go ahead and tell ArgoCD about this resource. Now we're gonna simply do it through kubectl apply in namespace ArgoCD, since ArgoCD has to learn about it, that resource, and then the resource that we want to apply, right? And now our React app is gonna get created. So let's check out the UI. You can also check the resource through the CLI, through the client, the ArgoCD client, but we're gonna use the UI. So here in the UI, we can see that it's our React application and it's synced. Now we can see that here's our service, right? And here's our deployment. And within the deployment, we have here this replica set. And for the replica set, we have two pods. Now for the replica set, we have a config audit report that we can find here, right? So you can view the config audit report here. And we have our vulnerability report that we can view here, and we can see all of the vulnerabilities within our application, right? So what basically happened is once we deployed our application, our workload, Starboard went ahead and checked the application running within the namespace, within the app namespace, because we told Starboard to monitor the app namespace. And ArgoCD provides this really nice visual overview of our reports within the ArgoCD UI. Now the thing is, Starboard creates more reports than just the two types of reports that we've seen, right? So it also creates a CIS report, a Kubebench report with Kubebench, also from Aqua, all open source tools. And you can view the reports in your Kubernetes cluster. It's another Kubernetes resource. However, in the UI, you can see that the config audit report and the vulnerability report belong to that replica set, to our deployment, right? So once we delete the replica set, the deployment, or update it, it will trigger a new scan for those reports, right? So similarly, if we delete it, all those reports are also going to be deleted because they're dependent on that replica set, versus the other reports in our Kubernetes cluster are not. So now the problem is with these reports that they are great, and we can access the YAML manifest with the report through the ArgoCD UI, but we don't really have a summary of how many vulnerabilities, for example, are exactly within that workload, right? Or within our application. So what we can do is, and what we're going to do now, we're going to deploy, where is it? We're going to deploy into our monitoring namespace our Prometheus custom resource definitions and our Prometheus stack chart with Grafana and everything that we need for our monitoring tools, right? So the reason why we have to deploy them separately is because ArgoCD right now, as it is, can't spin up, doesn't manage to spin up the CRDs before it's spinning up the other resources of Prometheus and so on. So there's kind of an issue. So what we're doing is we're going to deploy the CRDs first. And then once we have that, we are going to deploy the Prometheus chart. Now, similar to before, we're going to specify for our Helm chart our different values. They are all listed here, okay? So that's what we're going to do. Those two we're going to now deploy to our cluster. So the first one that we need is our Prometheus CRDs, right? And they are going to be deployed to our monitoring namespace inside of our Kubernetes cluster. Now next, we need the Prometheus chart, right? Now, before we deploy the Prometheus chart, we want to make sure that everything synced off the CODs, right? Because that was kind of the issue before. Once we make it sure for the first deployment, then all the other deployments should run smoothly. So here we have our CODs, and we're just gonna go ahead and sync them up. Well, we don't need to replace them in this case, so we just, okay. Now we finally managed to sync everything. So the CODs here are deployed to ArgoCDs are a bit moody, so you just have to retry the syncing process and it will work. It will work, I promise, since you can see it here, right? Now once we have those CODs, we can deploy the Prometheus Stack Helm chart. And we're just gonna do it through prom.yaml, specify that, and then it's gonna deploy our Prometheus chart with everything, with Grafana and all the other tools. Okay, so here's our Prometheus chart, and it's syncing up. As you can see, there are lots and lots and lots and lots and lots of resources. Oh yeah, it doesn't stop. So this is all going to be deployed through and managed through ArgoCD, right? We basically told it what version it has to deploy. Now we can obviously update the revision in our Git repository, but other than that, it will always fetch this revision and make sure that everything is defined declaratively through Git, right? If I change something manually, it will revert the change. That's what GitOps is all about. Now that we have both of it running, right? And this is nearly finished syncing. Now the last thing that we're going to deploy is the Starboard Exporter. And the Starboard Exporter is basically a Prometheus, like a metrics exporter that allows us to access the vulnerability reports from Starboard, from our cluster, in Prometheus. And once we have it in Prometheus, we can then create beautiful Grafana dashboards on our metrics, on our vulnerability reports. So we're going to just deploy the Starboard Exporter like we deployed everything else inside of our cluster, right? And now we're going to make sure it's also synced. Now again, you can use the CLI. You don't have to use the UI for syncing. So here's our Starboard Exporter. We're just going to make sure it's syncing up everything nicely. Now this will take a few seconds as well to spin up all the pods. And once we have that, we can now look inside of our cluster and we can access, first of all, the metrics endpoint, but then also the metrics through Prometheus, right? So we're gonna go to namespace, and within namespace, we have our Starboard system namespace to which we also deployed the exporter to. Now here we have the pods. Do we have a service? So we have the Starboard Exporter service. Now we can port forward that, similar to the previous command. We're gonna do 8000. So we're gonna see the metrics, and then we're gonna also port forward in monitoring namespace. We're gonna port forward Prometheus as well. So we're gonna look here at the service, and then we want to have the Prometheus one, the one that goes to 9090, port 9090. So we're going to forward that as well so we can access Prometheus. Now we can see here on localhost 8000, where we port forwarded basically the Starboard Exporter service to, we can see all of the metrics, everything that we are given from the Starboard Exporter. And then we can go and type vulnerabilities, Starboard Exporter vulnerability reports, and image vulnerability severity count, right? So we can look for that. And as you can see, the severity went up since the last time I looked. So we have 21 vulnerabilities that are of severity high, 2 of critical within our application, right? So now we can access also our vulnerability reports as our metrics, and now we can build a dashboard for our metrics from our vulnerability report, right? Now, I'm going to show you in the next video how you can build a Grafana dashboard for your vulnerability reports for the exporter. Now this is it for today. I hope this video was useful. As always, please make sure to hit the like button, subscribe to my channel for upcoming videos. Make sure to give Starboard a star on GitHub and ArgoCD a star on GitHub if you like those tools. Now I hope to see you in one of my upcoming videos. Have an amazing day. Bye bye.